Hello everybody and welcome. In today's video we are going to be finding the x and y intercepts, and we are going to be doing 3 examples which are shown on the screen. And before we begin, let's just go over quickly what an x and y intercept is. So the x-intercept is whenever a line crosses the x-axis. So in this case it is this point right here that is shown on the screen in blue. That is our x-intercept. And then our y-intercept is whenever it crosses the y-axis. So that is right here, and that is our y-intercept. So without further ado, let's get it. Example number 1, we have 5x minus 2y is equal to 10. And what we want to do here is find the x and the y-intercepts. So whenever we find the x-intercept, what we do is we set y equal to 0. And that makes sense because the x-intercept is whenever the line crosses the x-axis, and at that point, y is equal to 0. So let's go ahead and substitute. So we got 5x minus 2 times y, which is 0, and that is equal to 10. And now all we have to do is just simplify. So we get 5x, 2 times 0 is 0, is equal to 10. And to isolate x, we divide by 5 to both sides. These 5's cancel out. So then we get x is equal to 10 over 5 is 2. Now, the way you want to write your intercepts is usually as an ordered pair. So our x-intercept is going to be 2, which is the x value, comma, 0, which is the y value. So that's going to represent the point on the line there. All right, so our x-intercept is complete. Now, let's find our y-intercept. And it's the same exact process, except in this case, x is equal to 0. So let's go ahead and plug that in. We got 5 times x is 0 minus 2y is equal to 10. This is going to cancel. That's going to go to 0. So we get negative 2y is equal to 10. Isolate the y by dividing negative 2 to both sides. That cancels. And then we get y is equal to 10 divided by negative 2 is negative 5. And it's the same situation here. We want to write that as an ordered pair. So x is 0 here, and then negative 5 is our y value. So now we found our x-intercept and y-intercept. Therefore, this example is complete. Example number 2, we have y is equal to negative 3x minus 7. Now, we could just go ahead and plug in x equals 0 to find the y-intercept, or y equals 0 to find the x-intercept. However, one way that I like to do is I like to get the x and y term on one side and then have the everything else on the other side. So what I want to do first is I want to add 3x to both sides. And then what we get is y plus 3x is equal to negative 7. And from here, I want to go ahead and find my x and y intercepts. So our x-intercept is when we set y equal to 0. Okay, so now we're going to have 0 plus 3x is equal to negative 7. And that simplifies to 3x is equal to negative 7. And now we just divide 3 to both sides. And we get x is equal to negative 7 over 3. And our ordered pair for this is negative 7 over 3, comma, 0. And that's going to be our x-intercept for this one. So now let's find our y-intercept. And that happens when we set x equal to 0. So let's go ahead and do that. We got y plus 3 times 0. And that is equal to negative 7. So 3 times 0 is 0. We get y is equal to negative 7. So now we write that as an ordered pair. And we're going to have 0 for our x and negative 7 for our y. And therefore, we have our y-intercept and our x-intercept here. And this example is complete. Example number 3, we have 3x plus y is equal to 6. So to find our x-intercept. We set y equal to 0. So let's go ahead and substitute that. We get 3x plus 0 is equal to 6. All right, so when we simplify, we get 3x is equal to 6. To get x by itself, you divide by 3, divide by 3. These 3's here cancel. So we get x is equal to 6 over 3 is 2. And our ordered pair for our x-intercept is 2, 0. Okay, so that's our x-intercept. That's complete. Now let's find our y-intercept. And that is when x is equal to 0. So we get 3 times 0 plus y is equal to 6. 3 times 0 is 0, so we get y is equal to 6. And now what we want to do is write that as an ordered pair. So we get 0, 6. So we found our x-intercept here and our y-intercept here. Therefore, example number 3 is complete.